So in the last lesson, we learned how to multiply with whole digit numbers using log multiplication. And now we're going to look at how we deal with decimals in our multiplications. So let's take an example. 4.5 times by 0.74. So if we try to use log multiplication here, how does it start? Start with our pivot down the bottom. 4 times 0 is 0. 4 times 5 is 20. 4 times 4 is 16, plus 2 is 18. But this is where we run into our first problem, because what does this line actually represent? Well, that 4 here is actually 4 hundredths, or 0.04. So we can say that this line here was actually 0.04 times by 4.50. Now, should be very clear, 0.04 times by 4.5 isn't going to be 1,800. So there needs to be a decimal point somewhere. And so the question becomes, where do you put it? Is it going to be 180? 18? Could it be 0.18? Without experience and without doing a lot of maths, this isn't going to be obvious what to do here. So we have to figure out how we can manipulate that question into something we can actually solve. So let's first of all think about, what does timesing a number by 10 actually do? So let's start off with just the number 5. Just putting it here in our tens and units. So if I asked you what 5 times by 10 was, you would just say, no, it's 15. What does that look like here though, in our tens and units? What's actually happening is that by times by 10, we're taking our units and we're saying, let's increase the units by a factor of 10. Well, 10 units become a 10. So what's actually happening is that everything in the units column, in this case, is being moved across and diagonally towards the tens. So 5 units becomes 5 tens. 5 tens on their own, so we're now lost the 0. It should go here. And there's our answer, 50. Let's try a different example. Let's take the number 46. So if I asked you 46 times 10, you'd say 160. You've just been adding a 0 on. What's really happening is, as we pointed out, each column is going to be multiplied by 10, and it's going to be shifted along one. What's 10 times bigger than a 10? It's 100. So what happens is our tens column gets shifted into the hundreds. So that 4 is going to move diagonally down. So we're going to have 400. Same again with the units. The unit is also going to be multiplied by 10. That's going to be shifted across. And now we have 6 tens, or 60. And so I didn't touch upon a minute ago when I said the 0. It's because this row of hundreds, tens units is much larger. It goes the other way too. We also have tens. Normally we don't write anything after the decimal point, the same way that you might say 5 instead of 5.0. Unless it's necessary, you don't normally include the zeros after the decimal place. Here though, for completeness, by adding it in, really 46 is, you can think of it as 46.0. So the exact same thing happens. The 0 gets moved across, because a tenth times by 10 then becomes a unit. So that 0 moves down to here. And our answer is there, 460. So this same principle allows us to get rid of decimal places. Let's take the number 0.7. So 0.7, as we showed in the log multiplication method a minute ago, not something we really want to work with and deal with. But we can turn this into a whole number by multiplying by 10. You're normally taught in school that you shift the decimal point backwards and forwards. And as we pointed out a minute ago, what's really happening is that all the columns are being shifted to the left or to the right. But we'll get onto that in a second. So when we're asking 0.7 times by 10, taking our tenths column, and by increasing the tenths column by 10, it just becomes a unit. So we do the same thing. That 7 that was in the tenths column is now 7 units. And we do the same for every single column. So the 0 that was in the units, that moves diagonally across and becomes 0 in the tenths. Remember, anything times by 0 is just 0, so 10 times 0 is still 0. And we also then remember that there's actually something after the tenths column, hundredths. And again, we don't normally put the trailing zeros after, but we have to imagine this is actually 7.70. And that 0, again, just gets moved across the column. Here, keep the decimal places in. And we can now see how 0.7 has become 7. So this trick of moving your number across the 110 units columns works exactly the same way in reverse. For example, if you took the number 56, and so we wanted to divide by 10, we do the exact same process in reverse, because we can see that a unit is 10 times less than a 10. Same way that a tenth is 10 times less than a hundredth. A tenth is 10 times less than a unit, and a hundredth is 10 times less than a tenth. So what that means, we now move instead diagonally to the right. So our tens column, that 5, that's now going to move diagonally 1. Same with the 6. So 5 tenths is now going to become 5 units. And our 6 units now becomes 6 tenths. Remember to keep the decimal point across. There's our answer, 5.6. So in this example, if we want to take 42 and divide it by 10, everything moves diagonally to the right. So the 4 comes in the units column, the 2 comes in the tenths column. So we get 4.2. Now this is a little bit clumsy to write out every time we want to divide or multiply by 10. So if we ignore the top line and just look at what's happened here, instead of imagining that the number has moved one to the right, we instead think of it that the decimal point has instead moved one to the left. Now this makes it a little bit cleaner and easier to write down when we're doing calculations. So with our original question, if we're going to get rid of the decimal points, we can see that we want to move the decimal point 1 to the right here, 45, and 2 to the left, 2 to the right here for 0.74. So this is going to be equivalent of timesing by 100, so timesing by 10 originally to move the decimal point 1 across. For 0.74, this is timesing by 100. So what does this give us? This would give us 45 times by 74. Now, we start to see the problem here. We've only half done this question. Because if we work this out, this would give us 3,330. Clearly, that's not going to be the answer to 4.5 times by something slightly less than 1. So, how do we go from here back to the answer we want? Let's take any number, let's say 4. Now, if we multiply that by 5, it's going to give us 20. If we then divide 20 by 5, we're going to get back to where we started. 20 divided by 5 is 4. So what we can see is that if you do the opposite action to what you did, in this case, when we did times by 5, we then divided by 5, you left exactly where you started. So now we can see back in the question a minute ago, when we have that times 10 and times 100, if we now divide by 10 and divide by 100, we're going to be back to where we started. Let's see how that looks. So we're back to this stage again, where we've got 45 times by 74. And we made a note here that this came from 4.5, and we've had to times it by 10 to give us a whole number. And our 0.74 was times by 100 to give us, again, another whole number. So when this works through, again, more long multiplication practice, pivots on the bottom, 4 5s are 20, 4 fours are 16, plus 2 is 18. Move the pivot on 7, add the 0. 7 fives is 35. 7 fours are 28, plus the 1, plus the 3 is 28, 31. And we add the 2 together. This gives us 3,330. So what we did up here initially, where we times by 10 and we times by 100. Let's combine the two. Say that this is actually times by 1,000. Or, a better way in this case to think about it, this is the equivalent of moving the decimal point 3 times, and in this case we moved it 3 to the right. So, if we've moved the decimal point 3 times to the right, the opposite is going to be moving it 3 times to the left. So we take our answer of 3,330. The decimal point should have started out here, because this is 3,330.00. And now it gets moved 3 to the left. 1, 2, 3. And that's how we get our final answer. 3.33. We ignore the last 0 because after the decimal point, trading zeros beyond it are ignored. So let's do a different example. Let's do an example of 0.4 times by 0.6. So in this case, we can see that to get rid of the decimal point here, we're going to need times 10 to move the decimal point 1 to the right, and to get rid of the 0.6, another times 10 to move it to the right. So in total, we say that we've had to do times 100, because it's 10 times 10, or you can say decimal point has moved to the right 2 places. Now what does that give us, our numbers? That changes this to a 4, changes that 0.6 to a 6. So this we can do, without having to do long multiplication. We know 4 6s are 24. So, what we had to do at first was move the decimal point 2 places to the right. So to get the correct answer, we now do the opposite. Take the answer 24. So the decimal point would have gone here. Think of it as 24.0 something. And now we move 2 points to the left. So when the decimal point goes here, we can instead write this as 0.24. And that's our answer. Where this trick can help us is also going the other way around. Say we have 400 times by 2. Well, you don't know our 400 times tables, so we want something a little bit smaller. So we could instead manipulate this question and move the decimal point 2 places to the left, change 400 to the number 4. Change our question to 4 times 2, which gives us 8. Now we have to remember that in order to do this cheat, we divide it by 100, or you can say the decimal point moved 2 places to the left. And just a small note, just so you can remember what you've done. So now to get our answer at the end, we just do the opposite. Decimal point has to move 2 places to the right. So the number 8, think of it as 8.0, and so once to the right, we have to add a 0 in, and then again. Decimal point is now over here, and we can say that this is 800. So combining the techniques of moving the decimal point to the left and to the right to manipulate numbers to make them either smaller or larger, we can now deal with this sort of problem really quickly. 3,000 times 0.7. So, first of all, 3,000, a little bit on the big side, let's make it a bit smaller by dividing it by 1,000 in this case, or moving the decimal point 3 places to the left. So just make a note, decimal point, move to the left by 3. What about 0.7? Well, we can move that one place to the right to get rid of that decimal point. This is decimal point to the right by 1. So that turns our question into 3 times by 7, which is 21. Now what do we do about this? We have decimal points going both to the left and to the right. Well, what we do, we summarise what we've done. If you move the decimal point 3 to the left and 1 to the right, that's going to be a total of moving the decimal point to the left by just 2. 1, 2, 3 to the left, once back to the right. That's where we get an overall decimal point movement of 2 to the left.
So because we moved everything 2 decimal places to the left, we then had to move 2 decimal places to the right to give a final answer of 2,100.
So in the last question to practice, 0.67 times by 120. So again, give the video a pause and give this one a try. Okay, and now for the answer. So the awkward one here is the 0.67. So we're going to move the decimal point 2 places to the right. Give it 67. Now 120, it's up to you what you do with it. Because all this can be done is simplifying it down to 12. 67 times 12, we're going to have to use long multiplication anyway. So therefore, we can deal with this as 120 times 67 just as easily as 12 67s. But I'll do both methods to show you that it's consistent. So let's assume you leave it as it is with 120. Do your long multiplication. Starting off with the 0 as your pivot. 0 7 is a 0, 0 6 is a 0. Move the pivot to 2, so you have to add 0. 2 7s, 14. 2 6s are 12, plus the 1, 13. Move the pivot to the hundreds column. 1 7 is 7, 1 6 is 6. Adding these together, 0, 4, 0, 8. 8,040. Had we decided to deal with 120, actually before we go for that first, don't forget the fact we moved this 2 decimal places to the right, so therefore we have to move the decimal point 2 places to the left. 80.4 is our answer. Now the alternate method, if we decide to adjust the 120, get my pen out here, so that's 1 decimal place to the right. So that's going to give us the number 12. So the mass now becomes 67 times by 12. So when we follow this through, 2 7s are 14, 2 6s are 12, plus the 1 is 13. Move the pivot over to the tens column, the 1 here. So we have to add 0 in. 1 7 is 7, 1 6 is 6. Summating those gives us 4, 0, carrying 1, gives us 804. Now the difference on this one was that we moved 2 decimal places to the right and then 1 to the left. So overall this is effectively moving the decimal point 1 place to the right after both moves have been put together. So if we move 1 place to the right, we do the opposite, move the decimal point 1 place to the left, and gives us our same answer, 80.4. So it doesn't matter which way around you do this. The key important point to take away is that you have to just get rid of the decimals first from your question and make a note of how you had to move the decimal point in order to achieve that. Once the decimals are got rid of, then follow through with your standard long multiplication. And there you go, how to multiply with decimals.